Well, good morning. Sorry we're late getting started this morning. It's 11:38. Class was supposed to start at 11:30, and yet I'm the only one in the room. I kept thinking someone would show up. I went down to the restroom, did various things, and then my computer took forever to boot this morning. I don't know why. I was just at the doctor's office earlier, and I guess it was thinking I was there or something. It was looking for the sites I went through there, rather than here at the college. So anyway, we're here, and we're going from current slide, but nobody else is in the room, so let's just go on and get started. We're in Chapter 3, Determinants. 3.2 is Determinants in Elementary Operations, and we had just talked about doing row reduction, how that speeds up your finding a determinant. And I know that's what they want us to do on this one, but this is a 3 by 3. Those are pretty easy to do. But they want you to do row reduction or column reduction. The other thing, folks, I forgot to bring my glasses today, so I may be misreading things, so stand by. Here is matrix A. -3, 5, 2, 2, -4, -1, and this is on page 116, lower half of the page, -3, 0, -6. No, that's a positive 6. Okay. I think I got it right. Okay. Now, if we're trying to find the determinant of that, of course, the easy thing to do would just be repeat the first two columns and do your way we always do 3 by 3s. But they want you to do row reduction on this one, so let's do it. Now, remember, you can do either row or column reduction. This isn't having anything to do with equations or anything else. We're just finding the determinant of this matrix of numbers. Now, where I usually go is I look for the most zeros. You got 1 0 there. Now, what I would tend to do is want to make either these 2 zeros or these 2 zeros, okay? So you could get, you either do column or row reductions on that. Now, to get this to be a 0 is pretty easy using column 3. But getting that next one to be a 0 might be a little trickier. Okay? So I'm trying to see if that is the best way to go. Actually, now that I think about it, actually the easiest thing to do is get one more 0 in there. You don't need to get it a triangular matrix of any nature. Just get one more 0. And it's going to be really easy to get in either row 3 or column 2. I think it's real easy to get the row 3 if we just do 2 times column 1 added to column 3 and make that the new column 3. That will give it for us. So we'll do 2 times this. So this would become we're using column 1, so let's write it down. -3, 2, -3. Okay? We're not messing with column 2, so write it down. 5, -4, 0. Now, 2 times column 3 added to, 2 times column 1 added to column 3. 2 times -3 is -6 plus 2 would be negative 4. 2 times 2 is 4, minus 1 is 3. And 2 times negative 3 is negative 6, plus 6 is 0. That's all we need. That's all we need to get the matrix. Okay? Now, what we'll do now is use the third row and the first column, and we've got it up to a pretty easy situation. Okay, so we're using this minus 3. What is the sign? I know the minus 3 is a minus 3, but what is the sign of that position? Plus, minus, plus. Okay, so it's a plus sign, so we keep it a negative 3 times the determinant that you have here. Well, we could do that right here. That's 15 plus 16, minus 16. And that would be a minus 1, so that would give a determinant of 3. Okay? Sure enough, that's what they got. Okay? And that's how they did it, too. Okay. Now, let's move on to example 6 on page 117. I think I'll erase this because this is a much bigger matrix. A is now a big matrix. 2, 0, 1, 3, negative 2. 2, 0, 1, 3, negative 2. Negative 2, 1, 3, 2, negative 1. Negative 2, 1, 3, 2, negative 1. 1, 0, minus 1, 2, 3. 1, 0, minus 1, 2, 3. 3, negative 1, 2, 4, negative 3. 3, negative 1, 2, 4, negative 3. And 1, 1, 3, 2, 0. 1, 1, 3, 2, 0. I hope I copied it right, because without my glasses on, sometimes I miss signs and misread numbers, but it looks like I've got it pretty close to correct. Okay. Now, I look at this and say, where are my most zeros? Oh, here. 2 zeros in column 2, 1 in row 5, 1 in row 3, 1 in row 1. 1 in column 4, 5, okay? So I'd say let's go to eliminate, to make some more zeros here in column 2, okay? Now, doesn't really matter which way you go with this. My gut tendency is to pick the row with the sort of the lowest numbers in it. They're all about equivalent on that, so it really doesn't matter. So I would say let's add row 2 to row 3. Row 2 plus row 3 is the new row 3. No, that's 4. Row 3, 2 plus row 4 is the new row 4. Okay? So this would be, leave row 1 alone, 2, 0, 1, 3, negative 2. I hope that's right. Yeah, looks like it is. Okay? Leave row 2 alone, negative 2, 1, 3, 2, negative 1. And leave row 3 alone, 1, 0, negative 1, 2, 3. All right, glad you're here. I'm talking to myself. It's not a very intelligent conversation. Okay. And they did recently come in and swab the floors just as wet as they could get them, and I've been tracking them like crazy. I can't help it, but it's a mess. But it looks like where you are, it may have dried a little bit more than it has up here. All the desk and stuff shading it. All right, I didn't go over announcements, so let me do these quickly. The first one here, let me also turn on projector and swap the lights. Press the button and nothing happens. Sometimes that happens. All right, the first of the announcements is our volleyball team. I don't know if this is their full season or if this is a preseason or what, but I assume it's their whole season. The district tournament is coming up this weekend, Friday, Saturday, and Sunday, up in Boaz, Alabama. And this is the NJCAA District L/M tournament. Now, I know what L/M is. Now I've got it. Okay. All right. I'm guessing NJCAA means National Junior College Athletic Association. But that's a guess. I don't know what that stands for, but it seems like that would work. District, and then I guess this is ladies and men's. That's my best guess on L/M tournament. It's up in Boaz, Alabama, this Friday, Saturday, and Sunday. Now, we don't have a men's volleyball team. That's why I had never thought of that one before, but maybe some of the other schools do. But our team, the women, are very good. Yeah. So they, I hope, have a good shot at winning it all. But anyway, that's this weekend up in Boaz. All right. And then this was the email that came from Dr. Christina N. Mora. She's one of the newest cohort of merit scholars at UAB. I have no idea what that means, but she's a postdoctoral fellow is what I understand. Yeah, postdoctoral fellow. She came across this one-week summer opportunity for college students interested in biopharma manufacturing careers. Now, I take biopharma means the biological part of pharmacology, creating drugs, and that their manufacturing center, and they thought one of our students might be interested in applying. 1 week summer opportunity, the students paid $1,000 to go for 1 week. And the travel expenses are covered. So it's quite a good deal. The application deadline is sometime in January. She doesn't specify when, but she did send a link, website link that you can go to and get all the information I think you could possibly want to get. And if not, you can get enough information to contact someone to get anything you can't get. So anyway, those are the possibilities there. Sounds like a great opportunity. All right, I'd already started, and we're in Chapter 3, Determinants, Section 3.2, Determinants and Elementary, Operations. I had just done Example 5 at the bottom of page 116, and starting Example 6 at the top of 117. And I walked out of the house with the strap for my glasses, but without my glasses, okay? So I'm having trouble reading, especially plus and minus signs, and numbers like 2 and 3 that look a little alike. I may get them backwards, so keep up with me, okay? Keep me straight. There was matrix A. All right, good deal. Oh, mind it off, okay? It's not the most exciting place in the world, but... I hope it's sent. I completed the recommendation yesterday, and the message I got was there was a form, and then you were to attach a letter of recommendation. When I did the letter of recommendation, I attached it, said, the letter of recommendation has been received. Thank you very much, or stuff like that. But then when I got to the end of everything, which I was almost there, then when I went to submit it, it said, your letter of recommendation has been received. Thank you very much. It was the same message. I thought, well, wait a minute. is that saying the letter has been received or the application is complete? And I could not get, I tried calling the number, but it was after 5, no one would answer. So I emailed them and said, I'm getting the same message that I got when I attached the letter. Does that mean only the letter was, yeah, so I'll try to find out today.
Okay, they sent me an email saying that they received it, so I believe them.
Okay, you think it did?
Yeah,
all right.
they sent me an email.
I was feeling like it did. Everything seemed to go right, but the message was the same, and it said letter, not recommendation. So I said, is it missing the whole recommendation or just a letter? So anyway, we started on Chapter 3, Determinants, 3.2, Determinants and Elementary Operations. I did Example 3 on your YouTube video and had started Example 6. And I don't have my glasses today. I walked out of the house without them. I had a doctor's appointment this morning. I was sort of rushing to make sure I got there in time and forgot my glasses. So I'm not seeing too well. Here was example A given in the book, and I hope I copied it right. This is top of page 117. And it says find the determinant of this. Now, you could brute force, just start going to town, pick a row or a column, and start doing all the operations. That's the long way. Okay? The short way is to do row reduction to get as many zeros in a row or a column as you can. So my first approach is look for zeros, okay? This one has 2 in this row, 2 in this column, 1 in this row, 1 in this row, 1 in this row, and 1 in that column, but 2 in this one. That's my column right there. So what I want to do is get as many of the rest of these as zeros as possible. And the good news is you got 1s and -1s there. That's going to be real easy to do. So my first step was, now, which one do I want to hang on to and which of the others do I want to make zeros? It doesn't really matter here, I don't think. I tend personally to go with the one with the smallest numbers. And now that I look at it again, I'm wishing I had chosen this as the one to go with. But I chose this one, and it's fine. Okay? The reason I wish I had chosen this one, that has a 0 here, that we wouldn't lose them. The way I'm going to do it, we're going to lose that. But it's okay. All right. Or I could go back and change it, because I haven't started doing anything. Which you want to go with? This one, or that one? You choose. Doesn't matter to me. This row, 5th row? I think so too, because of that 0 right there. So I'm going to change my marginal notes here. I started this when nobody was in the room, and I wasn't seeing well. When I look at the board, I can see it a lot better. Okay, so now what we're going to do, and I will change this row too. Okay. What we're going to do is, if I could only see, all right. We want to hang on to this 1 because it's got a 0 in that row and change these other 2 to zeros. So let's deal with the first one, the row 2 first. Okay? What we'll do is, what would be the instruction to give here? We're using this 1. Minus row 5 plus row 2 will be the new row 2. So let's do that. -1 plus a -2 will be a -3. -1 plus 1, of course, is 0. That's exactly what we want. Whoa, look at this. -3 plus 3, 0. -2 plus 2, 0. And 0 plus a -1 is a -1. I think we struck it here. All right. Now, what do we do for row 4? Add them. So row 5 plus row 4 is going to be the new row 4. Okay, adding those two, you get a 1 and 3 is 4. Plus or minus 1 is 0. 2 plus 3 is 5. 2 plus 4 is 6. And 0 plus a negative 3 is negative 3. And we're going to hang on to the bottom row. 1, 1, 3, 2, 0. That 0 is looking a lot less important now, okay? So, what we do at this point, to find the determinant, you choose this entry right here. Wipe out that column. That's going to be easy. They're all zeros. And this row. Okay? And let's see what we've got. Okay, what's the first thing you've got to determine? What's the sign of this position? You know the sign of the number is 1, but what's the sign of that position? Well, plus, minus, minus, minus. That's the minus. So that's going to be a minus 1 times the determinant of what's left. And what's left here is a 2, 1, 3, negative 2. Negative 3, 0, 0, negative 1. 1, minus 1, 2, 3. Is there a question? See what we're doing? Is it making sense? Okay, you tell me the last one. 4, 5, 6, negative 3. Perfect. Okay? But that's some determinant to mess with. Okay? Now, what would be your next target to go for? Remember, adding a multiple of one row to another row does not change the determinant. Exchanging two rows, multiplying by a constant, or dividing by a constant, that changes the determinant. Not seriously, but this. This doesn't change it at all, so we can keep going. What do you look for now? The most zeros. And it looks like that's it to me, right? Now, which one to use then? I would say let's use this to eliminate that. Make that a 0. It's easier going from small to large and large to small. Okay? So let's do that. What would be, now this is a column operation. Okay? What would be your rule here? Okay, negative 3 times column 4. Add it to column 1. That's going to be the new column. I don't have room to write down there. That's going to be the new column 1. Okay, because all my signals, signs down there. So you see what we got to do? Minus 3 times that plus that. All right? So don't forget your minus 1. Minus 1 times. Well, here we can put a parentheses because it's no longer a determinant. Okay. Before we do anything there, well, no. I'm sorry. We do want to leave the determinant there. I forgot. Got to do our row operations. Okay. Column operations. So, we're changing the first column by minus 3 times column 4. What would that first entry be then? Minus 3 times minus 2 is 6, plus 2 is 8. Okay, next, minus 3 times minus 1 is, plus 3 minus 3 is 0. That's exactly what we wanted. Minus 3 times 3 is negative 9, plus 1 is negative 8. and minus 3 times 3. Minus 3 times minus 3 is positive 9 plus 4 is 13. That's not looking pretty, is it? Okay. That's the only change we do here. We write the rest of the columns as they are. 1, 0, minus 1, 5, 3, 0, 2, 6, and negative 2, negative 1, 3, negative 3. Okay. Now this is what I started to do before. Okay. What does that lead us to now? Don't forget your minus 1. There it is. That's where I wanted my 0 now. We're going to use this minus 1 to deal with that row and that column. What's the first question we ask ourselves? What's the sign of that position? Plus, minus, plus, minus, plus. It's a plus or minus 1, so it's another minus 1. So that will be a minus 1. And then what's the determinant you have left? 8, 1, 3, negative 8, negative 1, 2, 13, 5, 6. Okay. Came up some pretty nasty looking numbers, didn't it? But that's a 3 by 3. And even though it might be a little messy with those big numbers in it, it's pretty easy to do that determinant. So if you don't mind, I think I'm going to erase the 5 by 5 above it so I have some room to work. Is that okay? You got this? Okay. All right. Now, and what I'm going to do with my minus 1 times minus 1, that's a plus 1. Somehow you won't carry them around anymore. That's just a 1. Okay? So let's take this 8, 1, 3, negative 8, negative 1, 2, 13, 5, 6. Repeat the first two columns. This is how we do our 3 by 3s, remember? 8 minus 8, 13, and 1, 1 minus 1, 5. Now that I look at that, it'd be real tempting, wouldn't it, to minus 1 times this row, add it, minus 8 times this row, add it to that one. Those two would become zeros. That would get to be a pretty big number. So it wouldn't be too bad. Minus 8 times this would be minus 40 plus 13 would be a minus, what would that be, 27? Yeah. All right. Let's just do it this way. So, how do we do this? Your down diagonals here, that would be a negative 48. Gonna be some big numbers, folks. This one, plus 26. This one, it's gonna be a minus 120. 40 times 3, 120. Okay. Now, I'm going to get rid of those construction lines. Okay. Now, let's do the up diagonals, but that means we're going to be negating them. So, what's that one going to be? That would be a minus, but then when you negate it, it would be a plus 39, right? This one would be a minus 80. 2 times 5 is 10, times 8 is 80, and then the last one is a plus 48, isn't it? Okay. Well, I'll take care of these two, plus 48 minus 48, that adds to 0. Looks like the negatives are going to win here big time. That's going to be negative 200, and we're going to have a plus 65. That's going to be a minus 135, right? That's an awfully big negative number. Oh, but look at that. That's what we got. So, in the book, they did it a different way, okay? The first step we did pretty much the same. Except they isolated the one in row 2 like I had started to do, but I liked the idea of doing the one at the bottom better. So I did that. Okay. Now, I'm trying to figure out what they did next. They multiplied it's hard for me to see without my glasses on. Oh, they did something else here. I'm trying to see what it is. They also eliminated some down here by doing the second row and the fifth row. Now, but what I can't figure out is why they got a minus 1 to the 4th power there. And what we did was right, and I'm sure what they did was okay, but I just can't see where they got the 4th power there.
Because it's on the 4th row and 4th column. You know, you
Okay.
I plus J.
Okay. I can see this. There's the 1 from there. That's a plus 1 position. Was it because of the 4 zeros? I don't know. But that comes up being a 1. Okay. Anyway, you wound up with this.
Oh, wait. I see.
What's that?
They use the cofactor of the 5 because it's on row 1 and column 3. So they just did 1 plus 3. Just 4.
Okay, they did what?
You know the definition of the cofactor?
Right.
Is negative 1 raised to the I plus J.
Oh, that's right. Okay, yeah. They did that thing. Rather than do plus minus plus. Okay, I got it. Yeah, I forgot that's how they did this. And we had already done that. Okay, that, like I said, it's a 1 from there and then a 1 because it's plus minus plus. Okay, got it. Yeah, you're absolutely right. And they also did row reduction here. They did column reduction here, row reduction there, and came out with some extra zeros there. Did one more operation to here, and again they did their cofactor. That you're right. That's exactly what they were doing, and that was the plus position again. So you don't have to go through all that. And then they wound up with the same that we did. And then, like I said, they used the one in the middle. Yeah, they added these two rows together. And that gave,
second row,
yeah,
first row.
second row, the first and second row together. And that's how they got zeros at the top. I would have added the top to the second and cut zeros in the second row and the two. That would have been even easier. But it works just as well. And they came out with negative 135, just like we did. So as long as all your steps you take are right, you can take them, okay? Be sure that you take them right. But yeah, that's what that raised to the fourth. That was that. All right, that finished 3.2. Homework exercises here. Any of the odds, 1 through 19, they're all, the answers are in the back of the book, but they're all at calcchat.com for worked out solutions to those odd number exercises. Then do either 21 or 23. They're both at CalcChat. Any of the odds 25 to 35, they're all at CalcChat. There's a true or false 37, that should be at CalcChat. Any of the odd, either 39 or 41, they should be at CalcChat. 43 is a proof. If you want to do that, it should be at CalcChat. 45's finding a determinant of functions in a matrix, which is pretty good. And then 47 is a guided proof, and that's it for that. All right, let's move on. Any questions on 3.2? All right. Then let's move on to 3.3. Properties of determinants, as if we hadn't talked already about these. Okay? What we're going to talk about here are matrix products, when you multiply two matrices together, and scalar multiples, and how they affect determinants. In this section, we'll learn several important properties of determinants. Begin by considering the determinants of the product of two matrices. Okay? So first, they're going to give us matrix A. 1, negative 2, 2. 0, 3, 2. 1, 0, 1. Matrix B. 2, 0, 1. 0, negative 1, negative 2. 3, 1, negative 2. I don't trust my eyes today. Okay, I think I got it right. All right. First thing they said is find the determinant of each of these. So the determinant of A, and I don't know how you want to do it. It is pretty easy to eliminate this 1 in the 3, 1 position, and then it's a really easy thing to do. So you want to do that? Okay, how do we do that? Minus row 1 plus row 3 is the new row 3. Will that work? Okay. So what would that be? 1 stays the same. 1 minus 2, 2. 2 stays the same. 2, 3, 2. 0, 3, 2. What's the new row 3? No? You're adding minus row 1 to row 3. Minus 1 plus 1 is? Oh, I blew this one, didn't I? because that loses the 0 in the bottom. Sorry about that. It's still okay. It's pretty easy this way. And that becomes a 2. Negative row 1, that would be a positive 2, minus a minus 2 is a positive 2, plus 0 is 2. What's the last entry? Minus 1 times 2 is minus 2, plus 1 is minus 1. All right. So this is pretty easy. Wipe out that row and that column. Okay. And this is in what position? That 1 there? Positive position. So it's just a 1 times negative 3 minus 4 is minus 7. Okay. Actually, I should have had this being a straight line rather than a bracket. Okay. Negative 7. That's the determinant of A. Let's do the determinant of B. Now, again, do you want to do your expansion of 3's, or you I'd say that's the easiest way to go. I mean, there are other ways to do it, but let's just expand the first 2 columns, 2, 0, 3, and 0, minus 1, 1. And then do our determinant of B, which then B. Down diagonal would give us a, say again? 2 times negative 1 times negative 2 is not 2. Negative times negative is positive. You got the positive sign right. 2 times 2 is 4. Okay? Next, down diagonal. Zero. 0 times anything is 0. If you got a 0 in the diagonal, it's going to be 0. Okay? And this one will be, last down diagonal will be 0. Good. Okay, so we've got 4 going in. Let's erase those construction lines so we can read a little better. Okay. Put my slash back through my 0. Oh, I lost a number there. That was a 1, wasn't it? Okay. Now let's do our up diagonals. But what's true about the up diagonals? No, the opposite. Yeah. So, and this one will be positive because it's minus a minus 3, which is plus 3, right? Next one. No, this is, what will that be? 4. Another 4. Plus 4. And how about the last one? 0. So this gives us 11. The determinant of B is 11. Okay? Now, it says find the determinant of AB, which means the first, of course, we've got to first figure out what AB is. That's the product of A times B. So that's going to be 1 minus 2, 2, 0, 3, 2, 1, 0, 1, multiplied by 2, 0, 1, 0 minus 1, minus 2, and 3, 1 minus 2. All right. Now, will those multiply? Of course they will. Okay? What do they multiply to become? It's going to be a 3 by 3. So it's going to be the 1 entry will be a 2. So 0, if you're going across this row and down that column, be a 2 minus 0 plus 6. 2 plus 6 is 8. Okay, row 1, second column will be a 0, positive 2, plus 2 is 4. Okay, first row, third column will be a 1, that's plus 4. Yeah, 1 plus 4 is 5. Okay, it's going to turn out being a 1 because this is a plus 4 minus 4, that's going to be 0, and you had a 1 at the first, so that's just going to be a 1. Right? Okay. Second row, first column. 0. The next is a 0 because 3 times 0 is 0. And then the next is a 6. Right? Second row, second column. 0. Negative 3 plus 2 would be a negative 1. Perfect. And then the second row, third column would be a 0. Minus 6. Minus 4 would be a minus 10. Right? Okay. Okay. Third row, first column. 2 plus 0 is 2, plus 3 is 5. First row, second column, 0 plus 0, 1. And third row, third column, negative 1. You got it. 1 plus 0 minus 2 is minus 1. Now we need to find the determinant of that. Ew, yuck. It's still a 3 by 3, so it can be done by the old way of 8, 4, 1, 8, 4. 6 minus 1 minus 10, 6 minus 1. 5, 1, negative 1, 5, 1. That's expanding first two columns over. Now do your down diagonals. What's that first one? Eight. The next one, ooh, yuck. It's going to be a minus. $200. 4 times 5 is 20. 20 times minus 10 is minus 200. Third one, a lot easier. Plus 6. Now let's get rid of those diagonals because they're messing with my vision, which is not very good today. Okay, let's do our first up diagonal. And what do you know about it? All right, it's going to be a plus 5 because this is a minus, but you take the minus of that and that would be plus 5. Next one is going to be plus 80. And the last one's going to be plus 24. All right. Now, well, let's just do it. Okay, 80, that's a positive. These two add to be 30. 80 and 30 is 110. And Yeah, 127. Is that what you said?
No, sir, negative 77. I'm gonna
Oh, okay. Oh, you're just punching in your calculator. What did you get the answer to be?
negative 77.
Negative 77.
You got to check it and confirm it. I could be wrong on top.
No, you're absolutely right. And guess what? If you multiply the determinant of the first times the determinant of the second, you get the determinant of the product. So yes. When you said negative 77, I knew you did it right because that's what we got. So doing what I was doing, this is 80 plus 30 would be 110, plus 13 would be 133, and subtract that from 200, and you 123. Subtract that from 200, you get negative 77. I mean, add that to a negative 200, you get negative 77. You got it. Can't do the easy thing, adding, but I can multiply. Okay. So that leads us to, maybe that was just those determinants? I don't think so. So that leads us to Theorem 3.5, which says, if A and B are square matrices, okay, they've got to be square for you to do a determinant, okay? And they have to be the same size if you're going to add them. So they're of order n, okay? Then, here's your conclusion. If that's the case, then you know that the determinant of the product AB is the same as the determinant of A times the determinant of B. Okay? Ours illustrated that. The theorem says it's always true. Okay? And they do a little proof here, and I'll let you work through that proof because it's a bit more than I want to take up class time doing. So my eyes have started, I'm straining them like crazy to read, and they're beginning to hurt like crazy. Okay? But then comes another theorem, Theorem 3.6. The determinant of a scalar multiple of a matrix, what is that going to be? So it starts off the same way. If A, but now it's only dealing with A, is a square matrix, which of course it has to be to take a determinant of order n, okay? Goodness, I can't read. Eyes are aching. And C is a scalar. Then its conclusion is the determinant of CA. Now this is a little different from what you had before, is equal C to the nth power times the determinant of A. And you see, when I first looked at what they were doing on the previous one, I thought, they're using this thing we haven't even gotten to yet. But you're right, they were just doing their cofactor sign determination, which I had already determined. So yeah, but this is C to the nth power. Because if you think about it, when you multiply C times a matrix A, you multiply C by every element in that matrix, okay? And that means there's a C in every element in every row, and there's a C in every element in every column. Whatever you do, you're doing C to the nth power there, because there's n rows, n columns. So that's where that comes from. Now, whether we'll ever use that very much, not very many uses for it, but here's one. find the determinant of this matrix. A is, goodness, my head is hurting now. I'm straining so badly. 10 minus 20, 40. I hate it when I forget my glasses. 30, 0, 50, I think it is. And negative 20, negative 30, 10. I hope that is. Negative 20, negative 30, 10. Okay. Now, what I want to suggest to you, what do you notice about that matrix? Every element has a factor of 10. Okay? So you could factor out a 10 from this. And what would be left? 1, negative 2, 4, 3, 0, okay. Now, if what we want is the determinant of that matrix, and that's what they asked for, so the determinant of A would be from this that we just did. A is C times this, well, the matrix we're interested in, which is this thing, is C times A, so that would be, and what's the size of this matrix? 3 by 3, so this would be 10 cubed times the determinant of what's on the inside. And this is a 3 by 3, so I think it's fairly easy to, this is hard to see, is just to expand the two first rows. 1, 3, negative 2, negative 2, 0, 3. Oh boy, okay. Do our down diagonals, what's that? Now we're doing a determinant now, okay. Down diagonal, first one is going to be a, it's a 1, 0, 10. I don't know, that shouldn't be a 10, should it?
I thought it was 4. I realized it should be, I changed these in a 4.
That's, no, it should have been a 1. I wrote a 10 by mistake.
Yeah, because the 10.
Because you're factoring out a 10. Yeah, okay, so it's, but what does that come out being?
0.
0, okay. That first one's a 0. If I can get my pen back. The next one is going to be a okay. 2 negatives make a positive.
Oh,
So it's 4 times 5 is 20. Okay. The last down diagonal will give us a 9 times 4? 36. Okay. Now let's get rid of those. Goodness, my eyes hurt. Okay. Now let's do my up diagonals. First one's going to be a 0. Okay. Next one's going to be a, it would have been, but this is up diagonal, so it's going to make it positive 15. And then the next one's going to be a, only it's up also, positive 6. Okay. I don't need, that's really all I need there. All these are positive. Oh, man. 20 and 15 are 35, and 36 are 71, and 6 is 77. They seem to like 77 today. So this would be 77,000. A nice round number, right? Except I must have blown it, because something's not coming out right. What's that? I can't hear.
It's supposed to be a negative 36.
A negative 36? Okay. That was on this one here.
When you copied it, you didn't put a negative.
Ah, that's a negative 3 right there. You're absolutely right. You see it? Okay. So that would have been a minus 36. Okay. Okay. So that changes lots. Okay. Goodness, this hurts. Okay. So let's do it now. Negative 36 plus 6 will be a negative 30, plus 20 is a negative 10, plus 15 will be a 5,000. Okay, and that's what they got. Good for them. Okay. Oh, man. How am I going to make it through the afternoon with a 4.5-hour class? I don't know. I didn't bring my watch up either, so you let me know how time is going. What's we got? 5 minutes. Okay. All right. That was example 2, bottom of page 121. So theorems 3.5 and 3.6 is formula for the determinants of products of two matrices and the scalar multiple of a matrix. Those theorems do not, however, give a formula for the determinant of the sum of two matrices. Sum of the determinants of two matrices usually does not equal the determinant of their sum. That is, in general, the determinant of A plus the determinant of B is usually not equal to the determinant of A plus B. So don't ever try to make up a new rule like that, okay? And they showed you an example here where it wasn't. I guess it's worthwhile. That's the next. Yeah, let's do it just for the fun of doing it. If this is matrix A, 6221, and this is matrix B, 370 minus 1. Okay. What's the determinant of A? Pretty easy to do. It's what? Now, I must have copied, yeah. I can't read my writing. That's a 2, not a 3. Okay. Sorry about that. It was written as a 2, but my pen drags in it. Okay, so what's this determinant?
2.
2.
B is going to be
Negative 3. All right. Now, let's do A plus B. That's pretty easy to do too. Number one, you can do it because they're the same size. So that would be a 9, 9, 2, 0. So what's the determinant of the sum? Negative 18. Nowhere close to the sum of these two. So don't even try to make up any rules like that. Okay? The sum of two matrices, their determinants tell you nothing. Okay. So that's all they were showing there. All right. Now, determinants and the inverse of a matrix. I think I'll start with a clean slide. How much time do we have now? 1 minute? Okay. I think we're going to have to start at the top of that page next time. And maybe I'll have glasses next time. I sure hope so. Okay. Homework exercises then from 3.3 would be any of the odds 1 through 5. Any of the odds, and they're all at Calc Chat. Any of the odds 7 through 11. They're all at Calc Chat. And you can play around with 13 or 15 and see what you get. And then we'll pick up the rest of those next time. All right, good deal. Any questions so far? All right. I think the determinant chapter is one of the easiest chapters we got. So
that means everything else will be hard after this.
What's that?
Everything else will be hard.
Well, it's a different animal after this one. Yeah.